Alright, this is the second half of percent error calculations. Let's take a look at an experiment where your measured value ends up becoming greater than your accepted value, and let's see if we can come up with some explanations on why that would be the case. Again, this will be part 2 of the percent error calculations. Alright, so now let's say we have our flask, okay, and from our initial calculations before we did the experiment, okay, we determined that this would end up becoming 2.00 grams to end with. So this is our accepted value. This is what we're supposed to get. And let's say we did our experiment. And after we've done our experiment, okay, we ended up with more than the 2 grams that we were supposed to end with. We got around 2.25 grams. Okay. Alright, so what would be the percent error for your experiment? Well, let's plug in the values. So our accepted, again, is this value. So that's our accepted value, and this is our measured value. So the accepted value would be 2.00 grams minus 2.25 grams. And then all of that will be divided by our 2.00 grams. Okay, and then what we would do is multiply that times 100. So with our calculations right here, we'll note that this value ends up becoming a negative 0.25 grams in the numerator. And then what we do is we divide that by the 2.00 grams. And then multiply that by 100. Okay? And what that does is it gives us a value, okay, of a negative 12.5% error. Now note, again, this is a value that's negative. Now, because there's 2 significant figures in this numerator right here, we have to round our values, our final answer right here, to 2 significant figures. Again, we're doing rules for significant figures. So if there's 2 here, 2 significant figures here, 2 significant figures here, we need 2 in our answer. That means we need to erase this, okay, and report the value to be negative 13% error. Alright, now, again, that's 2 significant figures. Now let's take a look at our value. What does the negative 13% tell us about our experiment? Well, negative 13% tells me that our measured value ended up becoming greater than our accepted value. So whatever we had initially, okay, or I'm sorry, whatever we got at the end of our experiment, we ended up with more than we were supposed to get. Now, how is this possible? How is it possible that we would get a greater measured value than our accepted value? Well, again, it depends on the experiment. A whole lot of different things can go wrong during the experiment. Maybe you didn't react all of the reactants, so then you ended up with some of the reactants still left over along with the products in there. Maybe something was added into here, into your flask right here, that could have changed your measured value. I mean, there could be so many different things, but that's part of the error analysis. You want to make sure that you are able to explain in your experimental results why your measured value is greater than, okay, your accepted value. Alright, and that's the second part of our percent error calculations, and I'll see you in the lecture.